Hello students, today topic is electricity. In this video you will cover the basics of electricity and I will introduce you the different terms like voltage, current and power, and further we will see what are the related SI units of voltage, current and power. We know that electrical energy is due to the force of moving electrons, but when this flow of electron is controlled for the usable purpose, it will become electricity. So electricity is a controllable and convenient form of energy for a variety of uses in homes, schools, hospitals, industries and so on. It is just the flow of electrons which are moving through a metal wire in a controlled manner. This electrical energy can be converted into another form of energy for the usable purpose. For example, you can use it uh, you can use it to run a motor. In this case, your electrical energy is converting into the mechanical energy. You can also convert into the light energy using the light bulb. This circuit, the electric circuit, that is a closed path through which the electrons flow to run a electrical load such as electrical bulb. The common analogy to define electricity is faucet or tap. The water coming out of the tap can be thought of electrons and constitute current. The manner in which valve is opened up is analogous to voltage, as it is indicator of pressure or tension, and the power is just the work associated with it. That means you can say the amount of water that is coming out of the tap per unit time. The valve is closed to stop the water flow. Similarly, switch is used to stop the flow of current, just as is in a torch bulb. A continuous and closed path of an electric current is required, which is known as electric circuit. So current is expressed by the amount of charge flowing through a particular area in unit time. In other words, it is the rate of flow of electric charge. Note that the conventional direction for the current is from positive of the battery to the negative of battery, while the flow of electron is from negative side to the positive side. So I is basically the ratio of the charge per unit time, so it's Q by P. Now the SI unit for current is ampere, which is the ratio of coulomb per second. The SI unit for charge, you know that it is coulomb, and it is 6 into 10 to power 18 electrons. Charge associated with 6 into 10 to power 18 electrons, and one electron has a charge of 1.6 into 10 to power minus 19 coulomb. So if you want to measure how much current for a per unit time, you can multiply for that. Now talk about the voltage. See, charge do not flow in a copper wire by themselves, just as water in a perfectly horizontal tube does not flow. If one end of the tube is connected to a tank of water kept at a higher level, so that there is a pressure difference between the two ends of the tube, then only water can flow. Similarly, there must be some potential difference between the 2 points, and the electrical potential difference between 2 points is just the work done to move a unit charge from one point to the other. So it is the ratio of W divided by Q. Its SI unit is volt, which is given based on the name of a scientist, Alessandro Volta, which is an Italian physicist. Now, so electrical energy can also be in terms of voltage, can be defined as the energy resulting from the force between the two objects having the different voltages. Now the power is, if you want to define the power, it is work by time. Now the work done in a moving the charge q through a potential difference v is vq. So the power is just VQ divided by the time. So it is the product of voltage and current. The SI unit is watts. So hope you have liked this video. Now on the next topic we will study about the resistance, circuit diagram, Ohm's law, and factors on which the resistance of conductor depends. Bye, see you soon. Thanks for watching.